A very good morning to each of you gathered here virtually. It gives me immense pleasure to welcome young minds like you all to the webinar on empowering methodologies to transform students to space scientists, organized by School of Allied Sciences, Vinayaka Mission Research Foundation, deemed to be University Salem. It's such a privilege to have with us our honorable guest speaker for today, Dr. Unnikrishnan Nair, Director, Human Space Flight Center, ISRO. Space has always a fascinating world to all of us from our childhood. Many of you would have dreamed about spaceship, rockets, and so on at some point or other. This webinar is for you to get an understanding about the interesting and intriguing world of space and ways to become a space scientist of the future. Space science is a broad career field in which scientists investigate and conduct research about the universe. Physicists and astronomers are two different kinds of space scientists. Physicists study the natural laws relating to time, energy, matter, and space. They may work in theoretical areas of field or areas that can be studied using high-tech laboratory equipment to examine various properties of matter. Their work can be applied to how things are created, move, and function in space. Astronomers focus their studies on stars, planets, galaxies, and more. They may also monitor black holes, space debris, and asteroids. To become a space scientist, it is a difficult journey, but it is definitely worth it. If you are passionate to become a space scientist, just accept what you need to go and go for it. There is nothing better than accomplishing your goal. Dear students, there are a lot of opportunities out in the world. Explore them and choose the best that suits you. All the very best for your future. I extend my sincere and heartfelt thanks to our guest speaker, Dr. Unnikrishnan Nair, and also to Dr. K. Shivan, Chairman ISRO, for this wonderful leadership and guidance. Thank you, one and all. Have a great day.
Thank you, sir. Dr. Unnikrishnan S. Nair completed his MTech from Indian Institute of Sciences, Bengaluru, and a Doctorate of Philosophy from Indian Institute of Technology, Chennai. He served as the Program Director, VSSC, during a period 2017 to 18. He is a 20-member Bangalore-based group and assigned for the Gaganyaan mission. It's one of the prestigious space program of India, a Gaganyaan 2021 mission, a dream come true for the Kotanallur native. Presently, he is working as a director, Human Space Flight Center, ISRO. We are very much proud and honored to broadcast the encouraging speech which is going to deliver by Dr. Unnikrishnan S. Nair, Director, Human Space Flight Center, ISRO.
Professor Sendil Kumar, Director of School of Allied Health Sciences, and teachers and dear students. 12th April is an important day in the history of human spaceflight. You all know that the first man, Yuri Gagarin, whose photo is shown on this slide, he made history for the entire humanity by going to space and staying there for nearly 1.5 hours and returning back, the first man in space. That was in 1961, and this year it is the diamond jubilee of the maiden man flight. And as you all know, we are also gearing up for a human space flight mission. Indian Indians will be launched from the Indian soil and they will be brought back safely to the Indian shores within probably another 1 or 2 years time frame from now. The activities are going on. You should know what are the issues involved in going to space. There are many challenges. First, it is hard vacuum. That means there is no air for you to breathe. And you all know that you are surviving here because 1 atmospheric pressure is around your body. If that is removed, the body will explode. So you need an artificial atmosphere, 1 atmosphere. So you need to have a capsule which is pressurized, which should not leak. And at the same time, there is one more important issue is the weightlessness. That is, any freely falling body is having 0 weight. I hope you know what is 0 weight condition. Weight is a reaction on your body by the platform on which you are standing. If the platform is removed, you fall down. So you are in weightlessness or 0 gravity condition. All satellites are in a state of weightlessness or a free falling condition. But that can create problem because your body, majority of your body is filled with fluid. If there is no gravity, the fluids will float or it will accumulate at your upper body and then you are having many issues. There are other related issues like radiation and so many issues. So we need to address all these issues when you go to space. And your human body is not designed for conditions of microgravity. As it is shown in this slide, many things will happen when the fluid is shifting because of the absence of reaction or the 0 gravity condition. Your body face will become puffy and since more fluid is pumped up or is floating up, your kidney will start working more and then a lot of urination, the feeling of urination, so many things will happen. The body has to adapt to such situations. So if you want to become an astronaut, you should anticipate all these things and you will be trained to face such issues. So you can see many things will happen. In space, there is nothing like up and down. You are floating. So it can cause some people space motion sickness. Some people they are inside a cabin, they have the claustrophobia. Some people have phobia about height. So probably all of us cannot go to space. Some people will have to be trained, selected and then trained. And even your body also will grow by about 1 inch when you are in space because of the absence of gravity. On Earth, because of your weight, you are compressed and your height is less by nearly 1 inch. So many things happen when you go to space. There are many physiological challenges if you are returning after a long time. You know your body is such a intelligent system. If you use your hands for some hard work, you will have very strong hands. Similarly, if you are in space and under weightlessness, your body will think that you don't require so much strength in your bones, so your bones will become weak. And then after say a few months, if you are coming back, you will find it difficult to stand on Earth under gravity. So as shown in this figure, astronauts who are coming after so many months in space, they will be assisted and on ground, they will have to undergo special rehabilitation to come back and then cope up with the gravity. In India, this specific missions, we have launch vehicle, we have satellites, but how the satellites are in space, they are rotating the Earth at very high velocity, around 8 km per second, around 8,000 meter per second. And at such a height, so it has got kinetic energy, it has got potential energy. So if you want to bring back such things to a specific point on Earth, you need to systematically kill the energy. So this we had demonstrated in 2007 with a space capsule recovery experiment. Around 500 kg payload was lofted into space. It was in space for 12 days. Then it was brought back and then landed somewhere 140 km away from Chennai in sea, and it was recovered. So that has given us a lot of information about how to bring back a body from space. Similarly, in 2014, as shown here, in the first development flight of GSLV Mark III, a full-scale model of Gaganyaan crew module, we took it to 120 km and released at around 5.5 km per second. And it was made to come back, and then it was break by the, how do you kill the energy in when the capsule comes back to Earth? You can use the atmosphere. Here the atmosphere 100 km down, air is there. So if a body is entering into the atmosphere, because of aero braking or aerodynamics, you can reduce a good amount of the energy, and towards the end you can deploy some parachute and then softly you can land. So this has been demonstrated in 2014. Now the human spaceflight program in our country, on the left side what you show is the Gaganyaan, that is the immediate task where we will be launching 3 crew members to space and they will be brought back. But we are not going to stop there. We need to master the art of how to survive in space for long. So we need to have our own space station, and there are plenty of resources available in Moon and Mars. So we need to have a combination of astronauts plus robonaut to utilize the resources, bring back, and then so many things are possible. You know that towards this, many development activities are going on in the world right now to populate or to exploit the resources from other planets. So we have a program. For that, there is a separate center in ISRO called the Human Spaceflight Center. This center is just into its first 2 years. You can see what is shown here is the master plan, which is being which is coming up somewhere near Bangalore, maybe 200 km from here in a Chitradurga district. This center will be the focal point for all human spaceflight activities. And if you look at the immediate mission Gaganyaan, what is shown on the left side is the vehicle which is going to carry the Gaganyaan capsule, and the Gaganyaan orbital module or the capsule is shown on the right side. There you can see it has got 2 parts. That brown is the habitat which is pressurized and crew is residing, and it is around 3.1 meter or 10 feet diameter, and it has got a volume for 3 crew members, and it will be injected into the orbit by the vehicle. As shown here, you can see on the left side the vehicle is going up like any other launch vehicle, and it is injected. The orbital module has got its own solar panel. Those solar panels will give power, and after the intended orbital duration, say 3 days or 4 days, we have a deorbiting, because once it is in orbit, unless you disturb it, it will not come back. So we need to tilt the velocity vector by firing small thrusters, and you tilt the velocity vector. Once you tilt it, it will just fall under the gravity, and then you do the aero braking and then parachute and then come back and land. So this is the end-to-end mission which we are going to perform maybe next year or year after next. So the space will give so many problems. One is the space motion sickness. So you have 5 sensors. So these sensors may go into a conflict when you are in space. So there could be sensory conflict of sensation. So you cannot believe always your senses. So you have to depend only on the electronic instrumentation or the display unit, what is given there. Second, you have a pressurized chamber. Due to say meteorite hitting or so due to some reason, if it is depressurized, then your body is exposed to suddenly to vacuum. So, but you know that body cannot withstand vacuum. So the astronauts are wearing a special garment called flight suit, which is protecting the astronaut because the inside of the flight suit is pressurized. But still, when you are subjected to sudden decompression or depressurization, you may develop some symptoms called decompression sickness. So the crew or the astronauts will be kept in a separate chamber on ground, and it will be depressurized, and their reaction to that will be measured. And then there are issues like hypoxia. If you inhale more oxygen, you have problem. If you inhale more carbon dioxide, you have problem. So the system inside the cabin, you should see that you have provided an ambience like that is in atmosphere. And if you give out more carbon dioxide also, you can have problem. And then, as I said earlier, the body fluid will shift. So you need to have some special wrapping around on your thighs to see that the fluid is not lifting. When you come back, you need to take more fluid because already your fluid has been consumed because of excess urination in space. So you need to drink a lot of water before coming back. So when a living thing is introduced into a system, there are so many issues. That is currently what we are addressing now. So it becomes bioastronautics or space medicine is altogether different area where we are dealing with the survival of crew in space for short term as well as long term. How do we make the crew to adapt to the situation? By giving them special training. A training can extend for say 1.5 to 2 years. So this is the job done by the astronaut training facility or astronaut training center, where the selected crew will be trained to respond to the many situations that are coming up in a flight. One example I can give, I told you about the weightlessness condition or the zero gravity. How do you simulate say weightlessness condition in ground? It's very difficult. So one option, one method is like what is shown here. In aircraft interior, you remove all the seat and aircraft is ascending or pulling a parabolic path. Once it is up, you switch off the engine, then it is like a throwing a stone. It is it's just going up and falling down. So it is in a free fall condition. So you get around 25 to 30 seconds. By that time it is coming down, you start the engine, again pull up, and like that you can make 25 to 30 seconds small intervals. Like that, crew will be subjected to that zero gravity condition and their reactions will be measured, and they will be trained to don and doff flight suit and how to take food or water. Those things can be trained by such things. So all these things will come under the purview of astronaut training. So in our India, we have selected for youngsters from the Indian Air Force, and they have gone to Russia. They have undergone the 1 year training in Russia and they have landed back in fact March end. And in Bangalore, they will be undergoing extensive training in Gaganyaan module. For that we are making the facilities like many simulators, many systems will be made, and they will undergo training. They will be taught about the vehicle systems, many aspects, safety, how to take care of all those things. Because in a manned mission, the motto is not the mission success, but the safety of the crew. At any cost, crew should be safe. So unlike in a satellite launch vehicle, we take more care. We have more redundancies, we have more systems, we have heritage system in that, and we all will have a special provision to rescue the crew in case something happens to the vehicle. So that it is called human rating of the system. Like a automobile, there are so many systems to take care of the crew, like the airbag or the safety belt. Like that, a launch vehicle for launching a satellite and a launch vehicle used for manned mission will be totally different. So that is called the human rating aspect. So if you want, I know some of you would like to become an astronaut. So what is that qualification you would like to become? So you can have, say naturally right now, put some conditions like you should have a degree or a post-graduation. And then right now, see this pilot experience is taken as a reference. So if you have a few hours, maybe thousands hours of pilot or flying experience, that will add value to you. But important is how quickly you react to situations, what is your leadership skill, how effectively you can communicate. Because you don't have much time. With minimum words, you must be able to communicate. You must be good in teamwork. So there are certain personality traits that should be satisfied. And also we have put some conditions on the weight and the dimensions, because we cannot have the cabin for a very tall fellow like 7 feet or a very small person. So a nominal range, we like an Indian population, maybe 5 to 95% of the population will fall into that. So that way I don't think you will have an issue. And you should also have a good psychological behavior, like how you deal with your friends, how you talk to them, how jovial you are, you can see the Wing Commander Rakesh Sharma there, and he was telling how Yuri Gagarin was selected finally. At least a couple of people were there, but finally certain personality, how you jive with the team, all those things will add up and give marks for you to be selected. So you all can become astronauts irrespective of men or women. So there is no gender disparity, and it is only your will and your skill. Okay, I think I have these points from Bangalore. In fact, I would have loved to come and talk to you and meet you, but due to the current assignments as well as also to considering your safety and our safety, travel we are not encouraging much. Wish you all the best. Thank you.
Thank you, sir. I thank Dr. Unnikrishnan S. Nair, sir, for spending your valuable time and sharing your great views and encouraging the future young minds and your knowledge with us, sir. Once again, thank you. I extend my sincere gratitude to our beloved Dean, Dr. B. Sandilkumar, sir, for his constant support and encouragement. My sincere thanks to the teaching and non-teaching faculties for their everlasting efforts in making this event successful. I also thank the organizing committee, Mr. Karthikeyan sir, for organizing and taking much efforts in making this event successful. My heartfelt thanks to all the participants for your kind presence today. Thank you all. I now request everyone to rise for national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता